Today's lesson is a continuation from the previous one. So if you missed the previous lesson, I would put a clickable link so you can go to it and look at that video. And what we will be focusing on today, whether or not pairs of matrices can be multiplied, or how can we identify whether two matrices can be multiplied. We have two matrices on the screen. The first one has the elements 1, 4, and 8. The second matrix has the elements 4 and -3. So how do we go about figuring out whether or not these two matrices can be multiplied? First thing we should do is to write down the order of each of the matrix. And I did order of matrices previously. I will put that on the clickable field on top. We have 3 rows in the first matrix, each of the numbers in their separate row, and there is only 1 column in this matrix. So all the numbers are in 1 column, as you can see circled there. The second matrix has 1 row which has both of the elements 4 and -3. And the number of columns that this matrix has are 1 column followed by another one. So this matrix has 2 columns. Therefore, it is a 1 by 2 matrix, meaning it has 1 row and 2 columns. Please make sure and like, subscribe, and turn on the notification bell on all so you don't miss any of our upcoming videos. You can also share. We would greatly appreciate that. This is the next step in identifying whether or not two matrices can be multiplied. So the rule states that the number of columns in the first matrix must be equal to the number of rows in the second matrix in order for both matrices to be multiplied. So since the number of columns in the first matrix, which is the one that has 1 and C under it, representing column, that's one of the criteria. The other criteria is that the second matrix must also have the same number but for the rows. You'll need to look at what is circled, right? So that's the criteria there. The number of columns in the first matrix must be the same as the number of rows in the second matrix, and once they both have the same number, yes, you can multiply the two matrices. So in other words, if after you write down the order of each of the matrices and the number of columns in the first matrix is different from the number of rows in the second matrix, then the matrices cannot be multiplied. Moving on to a second example. So we are going to identify the order of the matrix once again. So you can figure out the rows first because you usually write the number of the rows first. So there are 2 rows in the first matrix which has the elements 2 and 3, and each of them are in their separate row. And there is 1 column. Both of the numbers are in the same column. So the first matrix is a 2 by 1 matrix. The second matrix also has 2 rows. +1 and -1 are in their own row. The number of columns that are in the second matrix is 1, where both numbers, the positive and -1, are in that row. So both of the matrices are 2 by 1 in terms of their order. Now checking to see whether or not they would be able to multiply. The first matrix has 1 column and the second matrix has 2 rows, and the numbers are different, therefore these two matrices cannot be multiplied. I am leaving you all with 2 problems from an exercise to do. Please work on it. Leave your answer either in the premiere if you are on while this video is premiering, or leave it in the comment section. If you have any questions, please do as well. Don't forget to like, subscribe, and share. I hope that this was very insightful, and look out for the next video.